From the air, it's the magnificent Mexican countryside. On the ground, it's rugged and inaccessible, an engineering and construction challenge.
Yes, as a matter of fact, the word challenge fits well given the conditions.
Imagine building a pipeline along mountainous slopes averaging 48 degrees, with half of the route straddling the trans-Mexican volcanic belt. That's just one of the tests facing the Tamazunchale Extension Pipeline project.
This project was a very challenging project for TransCanada in Mexico.
The 235-kilometer, 146-mile Tamazunchale pipeline extension links natural gas supplies from Mexico's east-central coast to two power generation plants and connects to Mexico's national pipeline system.
To navigate the steep slopes, in some cases the slopes had steepness in excess of 45 degrees. So we had to look at alternate techniques of how to construct and install the pipeline in these areas.
Murchie's team came up with two innovative solutions.
We had to find ways to make the construction work. We had a very, very steep slope that presented a tremendous risk and hazard to people and equipment.
Similar to a gondola to transport skiers, the three-tower cable crane system efficiently moves tons of steel pipe and construction materials up the 50-degree slope. The gondola is operated remotely to safely hoist loads of up to 8 tons. Up and down the steep, difficult slope, the crews have affectionately dubbed Waterloo.
Without that system in place, we should be still working on that slope in a much longer and a much unsafe condition than what we did finally there.
Entonces el contratista en esta parte optó, digamos, por
So the contractor chose to work directly in the trench on this section, and this has been productive because it is very complicated and we are working pipe by pipe.
The second major construction challenge was the remoteness of the construction corridor. We had to find ways to get equipment and people to the right-of-way and to construct in this remote area.
When the challenging slope seemed to present a challenge too great, the TransCanada team got innovative.
The second area of innovation that we employed was the drilling of a microtunnel.
A 672-meter tunnel was drilled through the mountain using a pipe jacking system along with a remote-controlled tunnel boring machine.
The rotating cutting wheel excavates the material at the tunnel face. Rock and stones are crushed by the discs of the cutting wheel and then ground down to the appropriate grain size in the cone crusher situated behind the cutting wheel.
The tunnel boring machine's rotating cutting head carved a path through the mountain, leaving a 2-meter diameter tunnel through to the other side. Behind the tunnel boring machine, concrete liners were jacked into place to maintain the tunnel's integrity. Then the actual pipeline was moved into place.
We looked at it going around, but you had to deviate the pipeline in such a long stretch that from a cost perspective it would have cost us more, and from an operating and maintenance perspective it would have cost us more in terms of long-term care for the integrity of the pipeline. That the safest, the best solution for the pipeline and the routing was to keep it in the same alignment.
Microtunnel was a very innovative and very new technique for TransCanada in particular, for Mexico at all. It's the first microtunnel performed in Mexico. TransCanada never used a microtunnel for this purpose in Canada or the US.
When the rains came, it made that component of the work extremely difficult to do.
As if the Mexican geography didn't offer enough of a challenge, Mother Nature stepped in to add her own curveball. 2013 was a very wet year in Mexico, including not one, but 2 simultaneous hurricanes battering the country.
Hurricane Ingrid was in the Gulf Coast and Hurricane Manuel on the Pacific Coast at the same time. It rained in the month of September in Tamazunchale 601 millimeters. So that made construction extremely difficult.
The weather wasn't even the final hurdle.
In this project we found many archaeological findings and sites.
One of the most exciting aspects of the Tamazunchale Extension project was the discovery of significant archaeological finds. In total, 53 sites were identified, mostly high atop the mountains. These finds required several pipeline route adjustments. Construction on the pipeline began in December of 2012. Along the route, 5 stations were built to service the line. While the Tamazunchale extension may have been a challenge, the TransCanada team expects to take a lot of the lessons learned here and put them to use in future pipeline projects.
A lot of these learnings and a lot of our experiences can be brought to Canada and the United States, other areas that TransCanada works. Especially the mountainous projects that are being planned in British Columbia, Alberta, in Canada. We should be able to bring most of these techniques that were used on this project, such as the cable crane, such as microtunneling, and our steep slope practices and procedures. So we're seeing that we're able to transition and move that across to benefit other projects in TransCanada.
As Mexico looks to energy reform to bring private investment into the country, TransCanada is well positioned to capitalize on our expertise in constructing and operating natural gas pipeline infrastructure in some of the harshest terrain on the continent.
A great project for TransCanada. This is a great step for the development in Mexico for TransCanada, and we're very proud to have built this pipeline project.